Good afternoon, everybody. Thanks for staying late. Appreciate it's a Friday, and hopefully what you've stayed behind to listen to is going to be really useful for you. All of the work that you've seen in the other stands, whether it's working in wood, working in metal, concrete, or other materials, all of the stuff around the built environment, that's the work that we do in designing how those pieces fit together, the shapes, how they fit within the bigger environment, and that's some of what the work that we do that I'm going to talk to you about, and that my colleague Andrew is going to talk to you about. If I just talk very quickly about Atkins, what does Atkins do? We're an engineering consultancy. Engineering consultancy is the brain power behind all of the design that you see in the built environment and in lots of other spheres. I'll talk about that in a moment. It's quite a big company, 18,000 people all over the world, 9,000 in the UK, so a big UK employer. And we work on infrastructure projects. We work on projects that try and save the environment in terms of reducing carbon, sustainability, and those kinds of things. And the company's 75 years old this year. I haven't been with the company for 75 years, but there you go. So what is an engineering consultancy? Engineering consultancy works in fields like transport, building railways, building roads, designing trains, planes, all sorts of vehicles. We work in sectors like energy, nuclear, oil and gas, renewables. We work in cities, we work in the environment. Why do we work in these sectors? Because there are lots of global challenges that the world faces at the moment. Things like population growth, things like mobility, energy shortages, water shortages. So the work that we do helps our clients in solving some of these challenges, either on a very small scale or really large scale relating to cities and countries and so on. And these are some of the images of some of the projects that we've worked on in the past. Sustainable buildings with their own power, road widenings, ships, marine, and some cars as well. If we touch on some of the projects that we've worked on in a bit more detail, this is the International Thermonuclear Reactor. It's an experimental project in France. This is the world's only fusion reactor, and Atkins is designing all of the buildings, all of the infrastructure to power that reactor. This is, hopefully you're quite familiar with this, the Olympics. Atkins designed all of the infrastructure around the Olympic Games Park. So he took the site when it was redundant, contaminated, lots of derelict buildings, and we designed how to clear that site, how to renew the river, how to landscape it, how to power the site, and to get the people around all the different stadiums so that the games delivered successfully. This is a bit closer to home, Birmingham New Street Station. There were some guys here a little bit earlier, I don't know whether you were here to listen to them speak about Birmingham New Street, some colleagues in another company called Mace, and they're building the station. We did all the design for it. It's a 5-year project just to do the design, and that is one of Europe's biggest building refurbishments. Thousands of people working on that project now, hundreds of designers working on it over a course of 5 years. We do some work on wings of aircraft. We do lots of analysis of complicated structures like this. We've worked on High Speed 2, designing the new railway line. This is one that we're quite proud of, the world's first 7-star hotel. We designed everything on that project. We did the architecture right from a napkin sketch in a restaurant to a client, right down to the man-made island that the building sits on. Another project in Dubai, this is the metro. We designed all the stations, all the viaducts, all of this kind of stuff. So what do engineers do? Those are all high-profile projects that Atkins works on. Lots of companies in the engineering consultancy sector work on these kinds of projects. Basically what we do is problem solving. That's what our engineers do. And how do we problem solve? We spot problems. If you look at New Street, lots more people wanting to use New Street Station. That station can't take that capacity, so we've got a problem. Well, how can we solve that problem? So lots of different problems like people mobility or using too much energy. So how can we save energy with maybe railway lines? These are the kinds of things that our engineers do. And the way we do it is we use knowledge, and you might get that knowledge from the GCSEs that you're doing or from the A-levels, and maybe a bit later degrees or master's degrees, or you might just get that knowledge from working on these kinds of projects in companies like Atkins. We do a lot of analysis, so we take that knowledge and we use software or maybe empirical analysis, and we look at problems and we look at answers to those problems through that knowledge and through analysis. And then we do clever things by trying to bring ideas from other sectors or different ideas, different approaches to problems that haven't been solved before, and we innovate. If we take an example, this is a simple example, Oxford Circus. So this is in London, and just going to show you a little video of what happened and what the problem was, how we did some analysis, and the solution that we came up with. So this is Oxford Circus a few years ago, but it's still like this now in the sense it's really, really busy. It's one of the main shopping centres in London. So middle of the afternoon on a Saturday, thousands of people and loads of traffic. That's a problem. Problem because thousands of people are using it. Are they using it safely? Can they move around safely and easily? Probably not with the layout as it is there. So, and if you look at it, let's look a bit closer. So we'll do some analysis. Too much overcrowding, people moving too slowly, getting each other's way, crossing the roads maybe without looking, and having to behave kind of not very safely. Well, we don't want that. We don't want people to get hurt. How can we change that? So what we do is we take the layout of a situation like that and we put it into a computer. And we need to apply some knowledge to that computer model. Well, what kind of knowledge do we need to know to solve the problem here? Well, we need to know about roads. We need to have some people who are experts in designing road layouts to keep the traffic moving. We need people who can understand pedestrians, who can model pedestrians to see how they behave. And then we come up with some ideas. The first idea, take away all of the street clutter. Make people move more easily. Next, let's narrow the roads. Let's make the traffic slow down a little bit. Let's create more room for pedestrians. So you can see we're starting to come up with a solution, but that's not the whole solution. We still need more. This isn't going to be enough to make this a really good junction for people to use. And this is the clever bit. We take a solution that's only been used once elsewhere in the world, diagonally crossing. So you prioritize pedestrians over road users. And those ideas, with a little bit of signal, traffic lights and some signal control, this is the kind of solution that we come up with as engineers. We analyze a problem, and then we come up with some clever ideas we maybe got from somewhere else, from other sectors, and then we apply it to something new. And the success of this is, if you go to Oxford Circus now, this is what it looks like. This is the computer generation, but that was really built. And not only that, but they're doing that in other major junctions in London as well. So you can see there how we take a problem, we analyze it, and we try and solve that problem using clever engineering. And that's what we do as engineers in consultancy all the time. Other problems that we've got, I talked about shortage of energy, I talked about carbon, and the need to be more efficient. One of the ways to do that is to take a lot of old diesel trains that run the railways and turn them into electric trains, bring in new electric trains. Well, not only do those trains need power, but we need to be able to provide a system that can run those trains. This is a project that I'm working on at the moment, Great Western Electrification, a really big problem with lots of really big challenges. Let's talk about some of those challenges. So we've got two sides to this. The first side is the future with these new trains that are being built. And the other challenge is the history and the heritage of that railway. This is Brunel. He designed and built this railway. Well, we can't just knock down what Brunel did. We need to be sensitive to the work that he did. And we've got to build a whole new electrification system around what he built, but that works for the new trains. So what have we got to do? We've got to power that system up. We've got to put new grid supply points in. We've got to electrify 1,000 kilometres of railway. We've got to put in 16,000 foundations and 14,000 structures. We've got to do all this while the railway is still running so that we don't affect the passengers any more than we need to. Some of the bridges are too low that go over the railway, so we've got to build new bridges so that the wires can fit underneath. 150 bridges to be rebuilt. Several tunnels, 7-tunnel, box tunnel, lots of historic tunnels that we've got to fit these wires through. And last but not least, we've got a very sensitive site in Bath, which is a World Heritage Site, where we've got to do this very sensitively. So these are the kind of challenges that we as engineers in a consultancy environment come up with all the time, trying to solve these problems, solve these challenges. And this is the kind of work that, if you choose this as a career, if you have good skills in engineering, in maths and sciences, if you're a good communicator, so good at explaining ideas to people and working in a team, then these are the kind of projects that you can get involved in. Now, I'm going to hand over to my colleague Andrew, and he's recently joined, and he's going to talk a little bit about his experience as an engineer in Atkins.
Thank you very much, Russell. Russell's quite old. This wasn't how I was going to start, but Russell's got quite a lot of experience, and I don't. So I joined Atkins only 2 months ago, along with 400 other young people. Am I standing too close to this? No? I started 2 months ago along with 400 other young people. That was quite a lot of graduates, quite a lot of apprentices. And so there's quite a lot of young people in engineering. One of the things I really want to impress on you is that engineering is a career for young people. I'm not saying that older people are no longer needed, but engineering really is a career for younger people. The fact that Atkins, as one of the largest companies, but certainly not the only designer in the UK, has taken on 400 young people is because there's real confidence that there's a lot of work to do. If they thought that the work was over, they wouldn't be employing new people. So I chose to go into engineering not just because there was a job for me, but because I quite wanted a job where I could solve problems. And I wanted the problems to be different every single day. So I don't know whether you've ever stood at the station and waited for the train and found that it's just not coming and thought, you know what, I could do this better. Well, that's pretty much what engineers do. Or looked at a building, like the really ugly concrete block that I work in, and thought, you know what, I could make this look a lot better. Or people in the built environment, or engineers and engineering consultancy do those things. They deal with these challenges every day. So often good design is something you don't really notice. You don't notice when something works. The only time engineers actually get any press at all, you only ever hear about engineers when something's gone wrong. And I think it's really important to understand that actually engineering isn't about things going wrong. Engineering is trying to make sure that things don't go wrong in the first place. And people tend to completely forget about it until they see that the one project is £100 million over budget. So engineering is something that really is about making things work. The ability to make things work is why I went into engineering, and I went to Nottingham University. I don't know whether anyone knows where Nottingham is. Everyone knows where Nottingham is, great. To study civil engineering. One of the things I found at Nottingham was that engineering companies are really keen on young people. And this is great for us because it means that A, they're taking on lots of graduates, lots of apprentices, but B, it meant that there were loads of opportunities for paid summer placement work to find out what a company does, and you can get paid for 2 months to do a job and find out whether you like it, and at the end of the 2 months you can just throw it away and go, it was crap. So I actually got the opportunity to do 3 of those, and some of those jobs that I did, I was paid for, they were great, and I decided I just didn't want to do it. I took a job with Atkins for a summer, decided I liked it, decided it was the one I wanted to do the most. I have to say that because Russell's here and he's my boss. But it was a thing that I really wanted to do, make a difference, actually feel that I was doing something. So having taken 3 great summer placements and taken a graduate job, I started at Atkins 2 months ago for, well, the foreseeable future, unfortunately. You've got to work for quite a long time, and it seems pretty good. What have I been doing since I started at Atkins? I've been working... Is anyone from Wolverhampton? You're from Wolverhampton, perfect. I'm working on a scheme at the moment, putting new signals into Wolverhampton so that we can run more trains more reliably and hopefully closer together. which is great for anyone that wants to leave Wolverhampton. One of the, to put these new signals in, I'm doing designs, calculations and checks to make sure that the right things are built at the right time and in the right place. But of course it doesn't always go to plan. This week we had someone on site who managed to roll a large forklift truck over on its side against a big retaining wall that holds the whole of the main railway between Birmingham and Wolverhampton up. So we had to try and work out how to make sure that the wall didn't fall down, and to check that we hadn't gone through any electrical cables or anything like that. So there's a lot of problem solving, not just in the planning, but also in the execution and making sure it really does work. Finally, if there's one thing I think is really useful to take away from the whole thing here, but especially today, is that engineering is an industry that A, needs young people, but because it needs young people, there's a huge amount of support out there for young people. So that might be through structured apprenticeships where you're paid to actually learn. Who enjoys going to school? I thought I'd get a response. No one enjoys going to school. Can you imagine if you were paid to go to school? Would you pay to go to school? Yeah, a few more people would actually go if they were paid. The great things about engineering is you've got that opportunity to do structured apprenticeships where you're paid to learn. Paid summer placements. I was paid to decide whether I wanted to do a job or not. Some of them I decided I didn't want to do, but I was still paid for it. Great opportunity. Or scholarships and sponsorships. If you think that university is actually quite expensive, it is quite expensive now. There's a lot of opportunities for scholarships, sponsorships, etc. To go to university, and they're not just about academic things. I certainly wouldn't have got a scholarship to go to university if it had been based on academic, because although I don't want Russell to hear, my A-levels weren't very good.
Neither were mine.
So I would certainly recommend, if you're interested in engineering, looking at options like the ICE, the Institute of Civil Engineers Quest scheme, because it was great for supporting my development through university and supporting my bank balance as well. Thank you very much for listening, and if you've got any questions, we'd happily take them.
Does anyone have any questions at all they want to ask Russell or Andrew? Any at all? Yeah, if you all want to come up and ask them privately as well, that's fine as well. You can come up on front of the stage. We also have freebies as well. There's mints and crisps available.
But only if you ask.
Okay, let's have a round of applause for Russell Jackson and Andrew Gill from the Atkins company there.